So today we are going to discuss sample and sampling technique. Here we are going to discuss probability sampling and non-probability sampling. In probability sampling, there is simple random sampling, systematic sampling, stratified sampling, and cluster sampling. In non-probability sampling, that is snowball sampling and quota sampling, convenience sampling. It is useful for UGC NET, CUET, CPT, and all economics exams. It is by Kautilya economics. And from the introduction, we can see that the statistics is of two types: descriptive statistic and inferential statistic. These are estimated by point estimation and interval estimation, and the test of hypothesis is done by parametric test and non-parametric test. Then what is descriptive statistic? The descriptive statistics are used to describe the basic features of the data in a study. They provide simple summaries about the sample and the measures. Together with simple graphics analysis, they form the basis of virtually every quantitative analysis of data. So, descriptive statistics are simply describing what is or what the data shows. With inferential statistic, you are trying to reach conclusion that extend beyond the immediate data alone. So we use inferential statistic to make influence from our data to more general condition. We use descriptive statistics simply to describe what's going on in our data. So inferential statistic is always study the population. Due to time constant, we are not it is not possible to study each and every item of the population, so that inferential statistic takes further at certain times population size is infinite or last to study. So now some sample survey method are used in case of inferential statistic, where we take a random sample from the population and study its features such as sample mean, sample variance, and try to estimate the parent population features. This branch of statistics is termed as inferential statistics. So we can see that these are the parameters and these are the statistics. Like in population mean, it is the population parameter. In sample, it is the sample statistics, sample mean. Population variance, sample variance. Population standard deviation, standard deviation, and so on. So a statistic is said to be an unbiased estimate of the population parameter theta if the expected value of the statistic is equal to the parameter. So if expected value of the statistic is equal to the true value of the parameter, that is, we called it unbiased estimate of the parameter. That is, expected value of population mean should be equal to the sample mean, so that it could be an unbiased estimate of the population parameter. Then what is census and sample method? So census survey method, or we call it complete enumeration method. So in this method we investigate 100% atom of a population, and thereby this method provides accurate exact information, since each and every units of population is being enumerated. This method requires a lot of time, money, and manpower, hence not a resource effective method. And then what is sample survey method, or we called it partial enumeration method. In the words of Fisher, Irving Fisher, sampling survey method is better than census survey in terms of speed, economy, adaptability, and scientific approach. Then what are the examples of sample over census method? Because the speed and less time consuming, sampling method are less time consuming and it is very speed. Then economical, it is less costly. Then easy administration, since less team size is to be administered, so easy in administration and better coordination between teams are there. Then reliability, while the census method sampling error are completely absent, in non-sampling error are also absent, then the result will be 100% accurate. However, in sample methods, we both have sampling and non-sampling error. So, between these two, which one is dangerous? Sampling or non-sampling? The sampling is more dangerous than non-sampling error. So what are the advantage? In census method we have only non-sampling error. In sample method we have only sampling plus non-sampling error. But in sampling method both sampling and non-sampling error can be controlled, which increases the reliability of the sampling method. Then what is sample? Sample is a unit that is selected from population. It represents the whole population. The basic purpose of sampling is to draw an inference about population. So what is sampling? Sample is a finite subset of population. It is a subset of population which has been selected from the population with the objective of studying the properties of population. So sample is a subset of population which the main objective of the sample is to study the properties of population, and it is the technique of selecting sample from the population which is called as sampling. So sampling is the technique of selecting sample from the population. Then what is the objective of sampling? The main objective of sampling is to fetch optimum result with the constraint imposed in terms of cost, money or resource and time. The objective of sampling is to aim at maximum possible information about the population using the given resource constraint. Then second one is to obtain best possible estimate of the population parameter. Using sample statistic, the basic idea of sampling is to calculate sample statistic which are as close as possible or are the best estimate of their corresponding population parameter. Out of many statistics, only the one which is the closest to the actual value of the population parameter is termed as best and unbiased. So it also involves some errors. So the in general the term error is not to be interpreted as inaccuracy or mistakes committed during a calculation or counting. In statistic and econometrics, the word error is used to denote the difference between true value and the estimated value. So, such error may emerge due to approximation in measurement, approximation in rounding of the figures, biases due to faulty collection, analysis of the data, presentation and interpretation of the result, then personal biases of the investigator or enumerators, etc. So there are two types of error, sampling and non-sampling error. The sampling error emerges in sampling method only. In sampling method, as only a small portion of the population is studied, there exists difference in the sample result and census result. So such difference are bound to occur no matter what the sample is drawn at random or that is highly representative. This error is attributed to fluctuations of sampling and is called sampling error. This sampling error is due to the fact that only a subset of the population has been used to estimate the population parameter and draw inference about the population. The sampling error is present only in the sampling survey and completely absent in the census method. So what is sampling error? These are the regions for which sampling error arises. First is incorrect selection of sample due to biased introduction by the use of defective sampling technique. Then use of faulty sampling methods. Error due to bias in the estimation methods. Like in sampling method, we estimate sample statistic. Thereafter, approximately it to the population parameter. Improper choice of estimation technique lead to sampling error. Then, how to measure this sample provided by standard error of the estimate. The knowledge and the estimation of the sampling error reduce uncertainty. The reliability efficiency of a sampling plan is determined by the reciprocal of the standard error of the estimate and is called the precision of the estimate. In sample survey, attempt is made to minimize this sampling error, which is the same as increasing precision of the estimate. In the diagram, we will clearly see that as sample rises increases, the sampling error goes on decline. So we will get a graphically we will get a downward sloping curve. So measurement of sampling error, it is measured by standard error. So standard deviation of the sampling distribution of mean, and coefficient of determination. In these two methods, we can measure sampling error. The non-sampling error are the result of human action. These errors can occur at any stage of collection, presentation, and publication of result. Thus, non-sampling errors are present both in census survey as well as sample survey. However, in the case of census method, non-sampling errors are in a greater magnitude as there exists a large number of items to be studied. So, there can be a error that occurs at any stage of collection, presentation, and publication of result. So, the following are the list of important reasons which lead to non-sampling error in census or sample method. First one is data specification, which being inadequate or inconsistent with respect to the objective of the study. Second one is error due to location of the units and actual measurement of the characteristic. Third one is error due to ill-designed questionnaire. Lack of trained and qualified investigator and lack of adequate supervisory staff will lead to non-sampling error. Then error due to lack of correct responses furnished by the respondent. Non-response bias occur if full information is not obtained on all sample units. If the objective of this survey are not stated clearly due to error in various operations in data processing such as editing, coding of the responses, punching of cards, tabulation, summarization, and observation. Then the errors may be committed during presentation and printing of the result. Clerical and complaining errors, wrong calculation or entries made during the process and analysis of data. Then publication error. These are the reasons of the error which lead to non-sampling error. Then absolute and relative measure of statistic. What are the absolute measures? Absolute measures, it is the difference between true value of a particular item and its estimated or approximated value. So absolute error is equal to the true value minus expected value. A is here the actual value and E is the estimated value. So A minus E represents the modulus value of A minus E after ignoring the negative sign. What is relative error? Relative error is the error that are reduced to pure number which are independent of the units of measurement. This is done by calculating relative error, which is defined as the ratio of absolute error to actual value. So relative error can be measured by the ratio of absolute error to the actual value. So absolute error is A minus E modulus value of A minus E divided by A. Then sampling principle. What are the principles of sampling? The principle of optimization takes into account the factor of efficiency and cost. Efficiency means it is measured by inverse of sampling variance of the estimator. The principle of optimization ensures that given level of efficiency will be reached with minimum possible resources and minimum cost. And cost, it is measured by expenditure incurred in terms of money or manpower. So the term optimization means that it is based on developing methods of sample selection, of estimation. This provides a given value of cost with the maximum possible efficiency. Then second one is principle of validity. By validity of the sample design, we mean that sample should be so selected that the result could be interpreted objectively in terms of probability. According to this, sampling provides valid estimation about the population parameter. This principle ensures that there is some definite and pre-assigned probability for each individual or aggregate. Aggregate means here we are taking population to be included in the sample. Then third one is principle of statistical regularity. So according to the principle of statistical regularity, we mean that a moderately large number of items chosen at a random from a large group are almost sure on average to possess the characteristic of the large group. This principle also its origin in the law of large number of the theory of probability. So there are two conditions, based on two conditions, that large sample size. As the sample size increases, the true characteristic of population are more likely to reveal. The second one is random selection. A sample should be selected randomly in which each and every unit of universe has an equal chance of being selected. Then fourth one is principle of inertia of large numbers. It is based upon the concept that as the sample size increases, the better result we will get. For example, if we have to study the weight of the students studying in a college, then fairly adequate sample of the students help us to arrive at good result. So these are the inferential statistics where from the target sample or population we are taking a sampling frame. From the sampling frame we are selecting some samples as an unit. So target population, it is the population of the interest in which researcher wants to generalize the result of the study. And sampling frame, it is a part of accessible target of population for study. The sample can be taken from accessible target of population and not from the entire target of population unless the researcher has access to entire target of population. So what is sample? It is the actual units selected for the study. So this sample is actual unit that is selected from sampling frame, and this sampling frame is selected from the target population. So there are two types of sampling techniques are there, non-probability sampling and probability sampling. What is probability sampling? The probability sampling technique is in this probability sampling technique, each element of the population has a fixed probability chance of getting selected as a sample. Not, it is not dependent upon the judgment of the researcher. Where non-probability sampling technique do not use chance selection procedure. They are not based upon probability concept. Indeed, these techniques depends on the personal judgment of the researcher. So there are different types of probability sampling and non-probability sampling. In probability sampling, there is multi-stage sampling, simple random sampling, systematic sampling, stratified sampling, and cluster sampling. In non-probability sampling, that is convenience sampling, judgmental sampling, quota sampling, and snowball sampling. What is random sampling and simple random sampling? So random type sampling, it is a technique of sample selection in which each atom has equal probability of getting selected in a single trial. In a random sample, each member of the entire population has an equal chance of being selected. So in random sampling technique, each atom has the equal probability of getting selected in a single trial. But in simple random sampling, every possible sample of the same size has equal probability of getting selected in all trials. Sample random sampling is on single trial and simple random sampling is on all trials. So simple random sampling is one of the technique of random sampling like stratified cluster and multi-stage cluster sampling. So what are the examples? Suppose there are 100 students in a class with 50 boys and 50 girls. The name of all students, irrespective of their gender, have been put in a bowl and the bowl has been thoroughly mixed. Now, if randomly one slip is drawn, then it is random sampling, yes or no? So, if one slip is drawn, it is a random sampling. If one slip is done, it is a random sampling as each and every student has an equal chance of getting selected in a single trial. But it should be a simple random sampling when each sample of size 1 has equal chance of getting selected in all trials. So let us suppose we are taking case B. If randomly 10 slips are drawn. So if randomly 10 slips are drawn, then it is called random sampling where each and every student have equal chance of getting selected in a trial. But it should be a simple random sampling when each sample of size 10 has equal chance of getting selected in all trials. So uh, every group of 10 atoms has an equal chance of getting selected in all trials. When it have equal chance of getting selected in all trials, it is called simple random sampling. When each and every student has an equal chance of getting selected in a single trial, it is called random sampling. Then what is stratified sampling? Stratified sampling technique is an alternative to reduce variability in the population. So using stratified sampling technique, sample can be made of more efficient estimate of the population mean. We are dividing this population. If the population is heterogeneous with respect to the variables or characteristic on the study, then the technique of stratified random sampling is used to obtain more efficient result. Like we are dividing it in different strata. Strata means the class or the group consisting of homogeneous atoms. It may be in the on the basis of geographical, economic characteristic, age, gender, income, occupation, etc. So the whole population is divided into different strata on the basis of the characteristic of the population, and thereafter from each strata atoms are picked up in random manner. So what are the steps? We will deciding upon the relevant stratification criteria such as sex, geographical region, age, courses of study, etc. Then dividing this total population into subpopulation based on the stratification criteria. Then listing the units separately in each subpopulation, and then selecting the requisite number of units from each population by using the appropriate random selection technique. So then consolidating the sub samples for making the main samples. The stratification improves the representative of the population by enhancing sample size of the strata, like equal allocation, proportional allocation, equal allocation, where all strata contribute to the same number of sampling element to the sample. Thus, if there are three strata, one third of the sample should be selected from each stratum. This is called equal allocation. Then proportional allocation, all strata contribute to the population. A number that is proportional to its size is the in the population. The large stratum, the more members it contributes to the sample. The sampling fraction remain the constant. Suppose there are 5 strata to be sampled and respective population size of the strata are as follows. Like in strata 1, 2, 3, 4, 5 are there. So strata sizes are there in strata 1. There is 5,000 units, then 1800 unit, 2000 unit, then 3500 unit, then 450. Like this different strata sizes are there, and the proportion of 5% are calculated, or this strata contributes 5% of sample size to the population. So sample size is calculated at 638. Then optimum allocation, this is given by Niemann. In optimum allocation, the strata contributes to the sample are proportional to the product of the strata population size and the variability of the dependent variable within the strata, that Ni gamma I. So large strata and strata with large variability will have large contribution to the sample, because the requirement of the good estimate of the population variety of the dependent variable, which is seldom variable before the sample is selected. So the optimum allocation is used in like this. So this implies optimum allocation gives the most efficient estimate. The stratified random sample is useful when list of units or individual in the population are not available. So it is useful in providing more accurate result than simple random sampling. The method is quite efficient provided the sample is reasonably large, that is more than 20 in every stratum. Then systematic sampling. Systematic sampling is the arrangement of the items in a population in a particular order. Therefore, every nth item from the order is being selected. It provides more even spread of the sample over the population list and leads to greater precision. Step involved: make a list of the population unit based on some order like alphabetically, seniority or street number, house number or any such factors. Then determine the desired sampling fraction, say 50 out of 1000. Also the number of k of the unit, k equal to capital N by small n. Capital N is the size of the population divided by sample size. So we are getting 20. So every 20th item will be selected from the population. Then starting with the randomly choosing number between 1 to k, both inclusive, select every kth unit from the list. If in the above example randomly chosen number is 4, the sample shall include 4, 24, 44, 64, 84 unit in each of the series going up to 984th unit. Then cluster sampling. Cluster sampling is the where the whole population is divided into mutually exclusive and collectively exhaustive subgroup or cluster. Thereafter, a random sample of cluster is selected using simple random sampling method. So after that, from the selected cluster, all elements are included in the sample. In multi-stage or two-stage sampling method, it is similar to cluster sampling. The initial steps are same or late. However, at the end, instead of enumerating all the sampling units in a selected cluster, one can obtain better and more efficient estimate by resorting to sub sampling within the cluster. This technique is called two-stage sampling or cluster, being termed as a primary unit and the unit within the cluster are termed as secondary unit. So these are the primary units, and these are the primary units, that is the cluster. From these we are selecting these are the secondary units. The whole population is divided into mutually exclusive and collectively exhaustive subgroups or cluster. Thereafter, random samples or group is selected using simple random sampling method. After that, from each selected groups, items are selected probabilistically, that is random selection of items from each group. Then what is non-probability technique? We will see the non-probability sampling in the next class.